Hi guys, welcome to lecture 10. So this lecture will focus on the advanced features offered in Java EE. Right, so this will be the lesson map. This particular lecture will cover two parts. The first is concurrency utilities. So we'll be covering introduction, components, the purpose of having concurrency utilities, and a simple example of explanation of the concurrency utilities. And moving on, we'll be also covering on the asynchronous servlet, and we'll talk about introduction, right? The purposes and the benefits of asynchronous servlet, and a simple example of the implementation of asynchronous servlet. Right. So the first part actually is touching on the concurrency utilities now. Before this concurrency utilities, right? So Java 1.5. So we talk about a bit of history of Java SE. So Java SE actually offers multi-threading features, right? So which means that we can create multiple threads, all right, to execute different tasks, right, at a different time. So that was the idea of having multi-threading in Java SE. So if one is to use the multi-threading, uh, then we got to actually the Java EE, right, has to work with Java SE multi-threading. So it will be a separate thing because Java EE at that time did not have what you call doesn't support the multi-threading, which means that the container does not have multi-threading support, right? So in that case, we will have a servlet, we will have a JSP web applications, and if let's say we want to have a situation in which a particular task to be run on a different thread, then we will actually work with API, Java SE API, right? Which supports concurrency, multi-threading features. But the drawback is the disadvantage is the Java application, Java web application has to communicate with API, which supports multi-threading, but this multi-threading is not part of Java EE. So therefore, right, it runs the risk of not being the programmed web application not being stable, and then the security is also a concern, right? Because it's not a part of Java EE. So in view of this, the Java EE now has concurrency utilities, which means that the container itself supports multi-threading, right? So we don't need to actually like work with um, in the external party, or we don't have to like Java web application doesn't have to like work with a conventional way, the traditional way, right? So the container itself supports the multi-threading, right? So that is what we're going to talk about over here, concurrency utilities, which means that the uh, the container will support multi-threading, right? Okay, so if you look at this diagram, the concurrency utilities in the container has several components, right? So first one is managed executor service. Then we have context service, thread factory, and we also have one more. I think it's a scheduled managed executor service. There's actually four, right? So all these components actually, right, sitting in the containers actually, right? So this will be well managed by the containers, right? Okay, so if let's say we want to use any one of the components, this is already there in the container. We just right away have to use it. We can actually use them through JNDI lookup or resource injection, right? So we just have to provide a default name for this component, right? So right away we can actually use it in the application. So that is a good thing about having these concurrency utilities, right, in Java EE. So all this actually, right, complying with Java EE, right, which is completely opposite, right, when we work with Java SE multi-threading, right, where it is actually is non-compliance Java EE, right. So now when all this actually within the container, then we will say is fully compliant Java EE. All right, moving on to the next slide. So the first component is, we call it manage executor service, right. So we need this component because when the client actually submits a task, right. So perhaps we don't want to utilize the thread, right, that is used to run do get method, right. So we want the task to be executed by another thread. So in order to have such situation, then we need to actually use manage executor service, right. So this component, right, will facilitate, right, to execute tasks, right, on a different thread, not using the HTTP worker thread, which actually which is used to run do get, right. Okay, the next will be a manage schedule executor service, right. So this one is quite similar to the manage executor service. The only thing is different is uh, we may actually want to run a particular service, all right, at a different time, right. So we can actually have the facility to schedule, right, to run, right, tasks using a different thread, right, at a different time, right. So that is a good thing about managed schedule executor service, right. Right, next, context service. Now this component will be useful, all right, just like the earlier components. So this one, for example, let's say a client is sending a task, or let's say submitting a task, right. So normally the task will be executed um, by an object, right. So when I say object, means there should be a class, right, to support. So the task will be executed, all right, will be supported by an object. So the task, let's say we don't want to execute the task immediately, and let's say we want to run the task at a later stage. So what we have to do is we have to um, pass the task to a service, and this service, right, can be executed at a later time, right. So in order to facilitate all this, then we need to work with context service, right. So this will be useful. It doesn't mean that we have to execute right away, right, a particular task, or let's say a particular service, right. So we can actually execute a service in a thread which have created, right, the service. But we can actually, the good thing about context service is we can execute the service on a different thread, all right. So in other words, we can pass the service from one thread to another thread. So that is the purpose of context service, right. So passing a service, a task, from one thread to another thread, right. Next, we have manage thread factory. So let's say periodically, right, you want to uh, create threads from time to time, right. So we can actually use manage thread factory, right. So from time to time you may actually want to create threads, all right, several threads. So if you want to manage those threads, then we need to work with this manage thread factory, right. Right, so moving on, um, to put it in a simple word, so why we need to have concurrency utilities? First of all, we need to have this so that we can actually execute tasks in parallel way, right. So by creating additional threads, okay. So the whole thing is actually conforming to the asynchronous programming model, right, concurrency utilities. Let's look at the example here. First of all, in order to um, implement, all right, concurrency utilities, so I'm going to use the manage executor service, this component, all right. So let's look at here. We have a task, so we create a class called callable task implements. So this class actually implements three things: callable, manage task listener, and manage task. Now this callable means that this particular method or this particular class, right, uh, will implement some methods which have the capability to pass back, okay, to another class. So we call callable, right? And simply we put it here callable big integer because it's going to, this method is going to return big integer, right? Okay, then we have manage task listener. So this is to actually to keep track, what you call the life cycle of threads, right? To keep track, right? So we want to know when a thread is created, or when a task is submitted, okay, when a task is actually completed, and so forth, right? Okay, then we have manage tasks, right? So this one we need to implement because we want this particular task, which is the big integer call, this method call, right, to be executed on a different thread, right? So we need to implement manage tasks, right? So the content of this particular class is, we will have a class variable called integer id, and then we will have constructor which will take in a single parameter here, right, integer id, and then we will have method call, okay, and this will actually do the summation. Okay, so upon receiving the id, so you'll go through several times the looping, and then we get the final value, and then we'll pass back the value back to the caller, right? So you have written summation. Now in between, actually I put it here system out print and thread current thread get name. So we just want to find out um, the name of this thread, right? So we want to differentiate, we want to know whether exactly, right, whether this thread actually is running on a different thread or not the same thread as in a, what you call in a do get method servlet, right? So we want to differentiate, right? Okay, the other methods that we have to develop will be the task submitted. So all this we have to create, we have to implement, because we already done here manage task listener, manage task, right? So we have to implement. So over here we just have a message here, task submitted, task done, task starting, right? So you will know exactly, right? So when a task is started, done, submitted, right? If some reason, let's say the server is not responding, the task will be aborted, so you will be able to see all this, right? Okay, moving on next. So next we have a servlet, all right, to actually to demonstrate, right, how manage executor service, right, is actually working. So let's look at here. It is an ordinary servlet, right? We have callable executor servlet extends, and then the important thing, right, we will see here resource name default manage executor service, right? So this is actually is the fixed name, right? Is fixed. If you go to the standalone.xml while flying, you will get to see this default managed executor service. So in other words, this actually is JNDI, and I say we actually making a reference to a managed executor service, right? So this managed executor service is actually offered in the server, right? It's already there. We just have to call, right? We just want to use the service, right? So we can right away use the name here, default managed executor service, and this is the code injection. Then we create a variable out of it. So we have manage executor service, right, executor. So using this, actually, right, we can actually we can actually use this method submit. So when you see submit, then new callable task, this is actually the class that actually discussed just now. It takes in one parameter, right, integer, right? So it will actually call new callable task. So if you go back to the earlier, okay, so new callable task, this one, it will call this constructor, right, and it will pass 5, and automatically, right, it will submit, right? So this submit executor submit, it will call automatically this call, right? It will do this, okay, so we'll execute this, so submit. So after this particular method, whatever the method that call, will actually return results, right? So we will have to use the future, right, future big integer, okay. because it may not actually done immediately, right? So maybe after a while, all right? So we have to use here future, and then over here we have the loop here while future result is done, right? So uh, we simply put sleep 1000 here, so because we want to see the effect, right, of executing this, right? So it will simulate that, it will done not immediately, right? So it will take some time actually to execute to get the result. So that is why I put thread sleep. So the current thread will go into sleep mode, right? Will go into the sleep mode. Then this method will be executed, and then we put here thread get name. So we want to find out the thread name of the in the do get, right? So obviously, right, a thread is required to run the do get. This is a service service name or service method, right? So you will see the thread name here, and then we have thread current thread get name, right? And obviously we'll see here future results, right? So this will be sending back to the client or browser, right? So you will see the output here, callable task return, and then of course you will also see the current thread name, right? So what we actually expecting here is the thread and this thread, right, should be the similar, and but this thread, right, should be running on a different thread, right? So this thread is actually provided by the managed executor service, right? So this thread compared to this thread is different, right? So this thread actually is we call it HTTP thread, right? That is needed, right, to run do get method, right? But this thread is to execute this method, right? So you have two different threads, right, running behind the scene. Okay, so you can also try out attempt using runnable interface. You can improve this. You can actually have what you call thread, all right, running using runnable interface. We can also try this manage schedule executor service, right? So which means that we want to run all tasks, okay, at a particular point in time, right? We can do that actually. We can manage the schedule, right? Running the task. Okay, so that will be left as an exercise for you, right? Okay, next will be the asynchronous servlet. Okay, now this we talk about servlet. It has been there for many years, right? Since Java EE has been introduced, right? But lately, right, the servlet, right, has been what you call kind of like upgraded to the a feature we call asynchronous, which means that the servlet now supports asynchronous servlet, right? So but those days the servlet does not have this kind of feature. We call it asynchronous, right? So with this, right, asynchronous, the servlet performance of the servlet will become much more better, because we will have a different threads, right? So when the client submit a task, then we don't actually make use of the HTTP thread, okay, which is required to run the do get, right? So instead we actually have another thread, all right, we'll create another thread, right, to run the task, all right? So that, because we know that HTTP worker threads actually dedicated pool, right, and it has limited number of threads, right? So which may become exhausted. So this is the problem here, right? So HTTP worker threads, right, is very limited. So we really need to use it effectively, right? So when you have when you run out of HTTP worker threads, so what will happen is performance is affected. When you have a lot of clients coming in, right, then you will start using a lot of HTTP worker threads, right? And then if it is exhausted, then right, the response time will be late and everything, right? So um, we can also increase the worker threads, right, by having more threads and everything, right? But this also will lead to another problem, right? You'll have system resources exhaustion, right? Simply does not scale, right? You'll take up the more resources of the host computer, right? So we need to find what do you call a better solution, right? Instead of increasing this, so we need to find another solution. So we look at the next slide. So the concept is here, right? The HTTP worker thread handles incoming requests and then it passes request to another background thread. So this is what you need to focus. So the client when submits a task, so the HTTP worker thread will handle by executing do get method or do post, right? And then will pass the request to another person, right, on a different thread. So another background thread. So this background thread, right, will be created automatically, right? This is what you call asynchronous. So we create another thread behind the scene, and then that thread actually will execute the task and then will pass back response back to the client. Okay. So this background thread, right, is responsible, right, to process and send the response, not the HTTP worker thread, right? So the HTTP worker thread, right, for initial stage will handle incoming requests. After they pass to the background thread, then the HTTP worker thread will go back to the HTTP thread pool, right, to get to what you call to handle other incoming requests from the clients, right? So this is the idea of having asynchronous servlet. All right, so moving on to the next. Okay, let's look at the example here. All right, now we have here we simply create a class called demo asynchronous service implements um, implements runnable. All right, so we look at here, we have asynchronous context. All right, and then you have runnable run. Okay, so this will create a separate thread and it will run automatically, execute this method, and then you carry out all these tasks and then print writer and all this. So I'm going to show you, right, so it's very significant difference between this and servlet. Now let's look at the servlet. Okay, now when you run index.jsp, right, so this is the file you have to run first. So demo asynchronous servlet and id you pass 5. So this will communicate with the servlet extends HTTP, right? And this servlet will receive the 5. The 5 comes from here, id 5. Okay, request get parameter, right? And we use the resource name default manage executed service, and we will print out this, and we want to find out the name of the current thread. And this is the uh, that we need to really focus here, right? So this is something different from the earlier one, concurrency utilities. So we request start asynchronous. So in other words, whatever information that we get from here, for example, the ID, all right, the ID, right? So whatever information that we get here will be passed on to another object. So we call it asynchronous context object. So in other words, the ID, right, will be copied to this object, asynchronous context object. So we can imagine that asynchronous context object here is like another kind of servlet object, is another type of servlet object. So whatever information will pass on to the another object will be copied. So at this point, when you have start, it will activate this. It will call this demo asynchronous servlet. Sorry, this demo asynchronous service. It will call this. It will call automatically, and then you pass the object to here from the servlet, and then you will run, and then you will execute this, and you will send the output back to the client. So in other words, it's not the servlet is responsible to send the response back to the client, but demo asynchronous service. So this acts like a servlet. It gets whatever things information from the servlet, right? It creates threads, runs, and then execute a task, and then send the output back to the client, right? So you look at here, the final thing is dot complete. So we need to tell the servlet that this job is done. So that is why we need to put dot complete, right? So the value and all those things. So you print out this. So this will be running a different thread, right? So when you compare to over here, right? So different thread here, do get, and here's a different thread. So by doing this, it will actually enhance the performance of the servlet, right? So the HTTP worker thread, right, is only will be involving, all right, handling the incoming request in the beginning stage. After that, it will pass to the asynchronous context object, and it will do the required um, process, all right? So it will execute and it will just pass the output back to the client. That's it, all right? And then it stops here. Right. So on top of this, we also have the new asynchronous listener, as I mentioned just now earlier, that we want to keep track. All right, um, the job or the life cycle of asynchronous context object. Right. So we have here a new asynchronous listener. Right. So over here, we are able to know, right, whether the asynchronous object is started or not, as a completed or not, and all those things. Right. So over here we have on start, on error, timeout, on complete. All right. So uh, this is the servlet, and then request, and we actually, if you look at here, executor, we are passing the we are creating an object of demo asynchronous service, and then we are passing the AC, right? So AC is like a asynchronous context object, and we are just passing to another class here, right? Okay, we need to create a class, and then we pass this object, right? And this object, right, will take care of everything, will do the necessary tasks, and then send the output back to the client, right? Okay, so you can also attempt using EJB asynchronous, right? So you can try that. Okay, so first you have to run this particular file, right? Right, so this is the in-class exercise. So I'm going to try all this to students, and then you got to post in the what do you call your solutions, all right? Your explanation for all this, all right, in the forum, right? So you will attempt all this. So this is something, this concurrency utilities is something that is a new feature in Java EE, right? And basically, the importance of this is to enhance the performance of web application, right? By having a multi-threading, right, support, right? So as we know that, in conclusion, right, as we know that the HTTP worker, right, is limited, right, and number of threads, right? So we have to find a different way, right, to enhance. So by having the multi-threading support within the container, right? So the important things here is within the container, right? So we manage the threads, right? We execute the threads, everything within the container. So the container takes care of the threads, right? Compared to the previous approach where the container does not have, this kind of support, and we actually were relying on the Java SE, right? Concurrency support, right? So it's out of the container, right? So it may not be a good practice. So now we have a better way, right, to manage the threads, right? So I wanted to uh, create a project in Eclipse, and then you got to try all this. Okay, try the first one, manage executor service, concurrency and utilities, right, by creating all these classes. Okay, and then try out with runnable interface, a schedule. Okay, after that you try with asynchronous servlet, right? So I think that's all. So I will stop here.